facility in the United States is only going 4 miles per hour. Only 4 miles per hour. However, the fastest tornado ever recorded in history went 318 miles per hour 13 years ago in Oklahoma. So we'll talk about that a little later. So how does it feel there, you guys? Dylan said it feels good. What else? Relaxing? What else? Let's use some science words, you guys. Like I said, hot or cold in here? It's very cold in here. That's because we have very large fans powering our tornado. What else? Is it wet or dry? It's kind of wet in here, but it's kind of dry at the same time because this is water vapor. So that means it's water in its gaseous state. So it's kind of equivalent to steam, only it's a little bit cooler. What else? She said it feels like how it feels when you come outside after a rainstorm, which is very, very true. Is it really windy like a normal tornado would be? No, it's kind of nice and still. And finally, did you guys notice that the longer you stood in here, the more the tornado began to wrap around you? Look up. It's wrapping around you as we speak. You guys did a very good job. You guys give a big round of applause. Come here, really good observation. Very good, you guys. So you guys take a step on the other side of the road with your families, okay? So, a tornado occurs when you have two opposing air fronts. Hot air rises while cold air reaches the ground. So that makes this really weird thing called a funnel cloud. That funnel cloud will pick up speed. As it picks up speed, it gets bigger and then it touches the earth. So I need 2 more volunteers because some very odd things begin happening. So I need 2 more people to come inside. Let's see. What's your name? Anna. Okay, come on in. Oh, where'd she go? Yeah, walk around and there's a speaker right there. Well, you guys can come in and get on the last one. Unless you guys want the last one. Where the Alma go? She's coming?
That makes it fast.
Okay, yeah, we have a lot of people. Autumn! There she is, okay. Good job, okay. And I'm going to come over here now. Let's see who wants to come over on the side.
You're already in there, Bill.
What's your name? Shelby? Okay, come on in. So, we're going to take a brief pause. If you have sensitive hearing, you may want to cover your ears because our Tesla coil is going to go off in about 15 seconds. If you have a camera, you can pull it out now and take a picture. It's located on the ceiling or the balcony where those big old rings are on the ceiling. I'm going to let it go off 3 times and then we'll continue. And those giant rings. Those giant rings where that orange light is. 5, 4, 3, 2, 1, look up! It'll go up 2 more times and then we'll continue.
Take a picture.
One more time. Shelby, you're going to get this part, okay? So, have you ever floated kite before, sweetie? Okay, so, come back over here with me. So, you're going to start to release the string like this, okay? But don't let go of the spool, okay? Now, Shelby, you're going to take this on inside the vortex, and if it flies out, you got to make sure it gets back in there, okay? You have to take it on inside the tornado, and if it flies out, you have to go and get it, okay? You got that? Okay, so take it on in. All the way in there. Okay, now let it go. Okay, so now, Autumn, it's your turn. You got to start releasing that string. Keep going. We've got a lot of it on there. It's really tall, so yeah. Okay, so, Shelby, you can take a step out of the tornado. So, what we're creating right now is known as updraft. So a lot of people always ask us, how is it possible for tornadoes to get to be so fast? Well, that depends on airflow. And airflow is what you guys can manipulate with the levers that you have in front of you. So we're going to see if we can change how the balloon is flying in a tornado. If you have levers in front of you, I need you to take the levers and hold them to the plus side. Hold them to the right. Hold them to that plus side. So keep going, honey. There's a lot of string. There you go. So what we're doing right now is we're adding airflow inside of our vortex. You may notice that when you push the levers begin to light up on the walls here. That lets you know exactly where